Let's start. Okay, before we get started, just keep two things in mind always. What I say in every video, if you already know it, you can skip it. First is DSA questions are not very hard by nature. What makes them hard is not knowing the trick behind them. And if we know the trick, the problem becomes easy. Else, life is a little hard. And second, if you ever feel stuck on a question, don't beat yourself, especially when you are new to the DSA or new to a particular topic, it's completely okay to watch the solution first, which will help you to recognize those patterns and build your intuition. So be kind to yourself and trust the process and keep going. So as always, we'll begin by understanding the question, what's given to us and what we need to find out. So
Okay, let's understand the requirement first. The question says next permutation. So, what do we mean by permutation? Permutation of an array of element is an arrangement of its member into a sequence or a linear order. Let's take an example. If we have an array of 1, 2, 3, these all are the permutations. We are just swapping the elements. That's all. And what we need to find out in this question is the next permutation. And what does it mean is the next permutation of an array of integer is the next lexicographically greater permutation to its integer. Okay, let's take the example. If we have the input as 1, 2, 3, then its next lexicographically greater permutation will be 1, 3, 2. And likewise, this is the next, this is the next, this is the next. Yeah. So hope you understood the question, and if not, feel free to pause the video and take your own time. So okay, now let's see how we can approach it. So can we traverse the array from the last until we find an element that is less than the value to its right? And once we find that element, we need to swap the element with the next greater element to its right. And at last, we will reverse all the elements to its right so that the combination is smallest. So, what I mean by that is, let's take an example. So, if we have 1, 2, 3, then 3 doesn't have any elements to the right. Okay, now 2, we can see that 2 has an element to its right and which is greater. So we found one element which is less than the value to its right. So what we'll do in the next step, we just need to swap this element to its next greatest element to its right. So after swapping both the elements, this is the result. And at last we also need to reverse all the element to it right, but here we have only one element, so it won't affect the output. So this is the final result only. So let's take another example. So in this case, as we see, we couldn't find any element that is less than the value to its right while traversing from the last. It means that the array is already in the last permutation. So that's means it's already in a strictly decreasing order. So we need to reverse the entire array in that case. So we reverse the entire array in that case. This is the result. So let's quickly visualize the logic. So we have the code snippet handy with us, and let's see line by line what we are doing. So here we are defining the input, we have the size, then we are iterating whole array from the last, and we are finding out an element which is greater than to its which has the value greater than to its right. Once we find it, we'll break it and store it in that index into the ith value. And in case if it's on the last permutation, then we'll completely reverse the entire input. But if it's not on the last permutation, we'll try to find an element to its right which is greater than the that element. Once we find that element, we'll break it and we simply swap it. And at last we will reverse all the element to its right, and so the combination is smallest. So for reversing it, we'll first find the sublist from I plus 1 to n, and we simply reverse that sublist. So that will give us the final output as 131, because in the sublist we have only one element 2. So it doesn't affect the result. But that's all. If you can analyze it, and in case you have some doubts, feel free to reach out in comments.